You can see right here on the board, we are talking about three things at the same time. And I'm going to take my time to explain what we are talking about. If you have followed up on my video on SECO, I strongly believe that you understand every bit of what I'm talking about now. It's a very simple thing, but what I'm going to do in this question, I want to show you what we are actually looking for. The length of an arc, then also the perimeter of the sector, then the area of the sector. I'm going to draw it according to the question that has been given to us. I'm going to draw with the parameters, that have been given to us. I'm going to draw the circle for you to understand what we are actually talking about. From the question, we saw that our angle, which is theta, was given as 105 degrees, which is 105 degrees. Then the radius is actually 6 centimeters. Don't forget, I have explained in my previous video that when we take a portion of the circumference, we are talking about the arc. So let's assume here is A, here is B. So to get this length of this arc, it is what the question is all about. We're talking about the length of that arc. It has a formula. We all know that when we are looking for the length of the circumference of a circle, the formula of the circumference of a circle is equal to 2 pi r. Circumference of a circle is equal to 2 pi r. But if we are looking for the length of an arc, remember I told you in my previous video that the length of an arc is actually a cut out portion from the circumference, which is the boundary around the circle. In fact, that is the reason why we call the circumference of a circle the perimeter of a circle. Circumference of a circle is also called the perimeter of a circle because it gives the boundary around the circle. By formula, the perimeter of a circle is equal to 2 pi r. Also perimeter of circle. Perimeter of what? Of circle. So we call it circumference or perimeter of a circle. That is not what I'm doing. What I want to do is I am looking for the length of the arc and also looking for the perimeter of the sector, then the area of the sector. Don't forget, like we said, let's talk about the length. Length of an arc. Length of an arc. The formula I want to give you first of an arc is equal to length of an arc is equal to, let me put it here. The length of an arc is equal to theta over 360. Theta over 360 times 2 pi r. Theta over 360 times 2 pi r. What we are simply saying is that if we want to calculate the length of an arc, not the full circumference, just like we have AB, that small curved part is called an arc. I have explained that in a previous video. So we want to get the length. It is the formula, the angle which that arc subtends. When you hear the word that the arc subtends an angle, is like in a literal term, it carries the angle. So the arc the angle it subtends is actually 105. So we'll now write it like this. Length of an arc is equal to 105 over 360 times 2 times 22 over 7. 2 times 22 over 7. Don't forget that the times radius. Our radius is 6 actually. Our radius is actually 6. So you will see that from the formula, our theta, which is the angle, is 105. Then the 2 is there before 2 times pi. Our pi is 22 over 7. The radius is 6. So we are going to reduce the fraction now. Let's see how we can divide it. Yes, I know that 7 here will go here 1, 7 will go into 105. The log division method I've taught in my previous video, you can go 1 time, remember 3, put that 3 in front of 5, it becomes 35. So 7 will go into here, that is 5 times. So 7 will go into 105 15 times. Then let's reduce it. 6 will go into here 1. 6 will go into here 60. That is 60. We are trying to reduce the fraction. We'll cancel that. And what is left again is that 2 here 1, 2 here 30. 2 here 30. So we are reducing the fraction. 2 here 1. You can just multiply through and divide by the multiplication of 360 times 7. For me, I'm trying to reduce the fraction without using calculator. That's why I am doing all of this. So now I have 30. So what I'm now having left is 22 over, okay, I'm now having 15 times 22 over 30. 15 here 1, 15 will go into here 2 times. So when we do that, 2 here 1, so my answer is actually 11 centimeters. So what I'm having there for the length of an arc is actually 11 centimeters. If you want to do it in your own way, you can say 105 times 2 times 22 times 6. Whatever you get, you keep it there, all over 360 times 7. Then you divide. You are going to arrive at 11. So what we have succeeded in doing here, just because I'm trying to reduce at least what I can cancel out, I've been able to get that. So that is exactly what we have there. Then the next thing we want to talk about is we're talking about the perimeter of a circle. I haven't got the length of an arc. The perimeter of a circle is not difficult. The perimeter of a circle is not difficult. I've talked about the length of an arc. The perimeter of a circle is what we want to talk about now. Now we have gotten the length of an arc as 11. And when we talk about perimeter, don't forget, it talks about the boundary. Now we are talking about a sector. By now, if you have actually followed up on my video, you will know what a sector is. A sector is a region bounded by 2 radius and an arc. As you can see, this is the 2 radius there. This is the radius, and this is an arc. What we are having in this shape, if we are to cut it out, is actually called a sector. Remember what we just got is an arc, but now we're talking about a sector. And remember that radius is the same anytime. So if you get radius anytime, because it's any point, any straight line joining any point of the circumference to the center of the circle, that is what radius is. So I guess you know that. So what we have done is that the perimeter of sector is now equal to 6 plus 11. That will now give us 12 plus 11, which will give us 23 centimeters. So the perimeter of the sector, as you can see here, is very simple. Is 23 centimeter. 23 centimeter. Then the last aspect I want to talk about is the area of the sector. The area of the sector, I don't know, oftentimes people normally miss the area and the length of an arc. I want to give a clear explanation of what the formula is all about here. Now, we talked about the perimeter of a sector. Remember, perimeter, the boundary. This is a sector. Then the length of an arc is what we did here. In case you don't know what we did. Here is 6, here is 6, here. So in the perimeter, you look for the boundary around an enclosed shape. The boundary, the length of the boundary around an enclosed shape. That is what we call the perimeter. Now, we talk about the area of a sector. Area of a sector is actually equal to theta over 360 times pi r squared, not 2 pi r this time around. We did it, the other one was derived from the length of a circumference, that is for length of an arc. Now we are deriving the area of the sector from the area of a circle. The area of a circle is pi r squared. So for the fact that we are now cutting out a portion from the circle, which is the sector, as you can see, I have illustrated on the board, it's now theta over 360 times pi r squared, not 2 pi r, pi r squared, not 2 pi r. Pi r squared is different from 2 pi r. So take note of that. Now we are going to substitute everything accordingly now in our formulas. When we do that, we are going to have 105 over 360 times 22 over 7 times 6 times 6, that is radius squared. That is what it actually stands for. So when you do that, you see that we are going to have, here will be 36. So it will now be 105 over 36, that is 22 over 7 times 36 over 1. 36 here 1, 36 will go to here 10 times. So this one we have said it before, we went in 15 times. So we now have 15 times 22 over 10. That is what we have. Of which you know 5 will go to here 3 times, 5 will go to here 2 times. 2 here 1, 2 here 11. So now 33 centimeter square. So the area of that sector is actually 33 centimeter square. Knowing fully well that we put our area in square form in our unit, that is why it is like that. So I don't think, from what you have seen there on the board, you will see that it's very simple for us to solve calculations like this. I will actually create a platform where questions can be asked. Maybe you snap the question there and then I will do calculations on that. I will explain it with the videos and send it so that you understand every bit of what I'm explaining. This is the much we can talk about the arc, the length of an arc, the perimeter of a sector, and the area of a sector.